Hello everyone, welcome to my YouTube channel AI Era. In this video, we can discuss how to create machine learning model to predict house price. In this video, we can use a linear regression analysis to predict housing price. Therefore, you get better intuition how to practically implement supervised machine learning to solve real world problems. So without further ado, we can start our session. In previous video, I can explain that what is machine learning, its type and its real world application. Those who did not see what is supervised machine learning, those can see my previous video, the link is below in description. So implementation of supervised learning, I can use a Python and a Jupyter notebook. You can use a various IDE such as PyCharm or Spider. So let's start the coding. So here I am in my Jupyter notebook. So in basically to predict housing price, we use the Boston dataset. There are so many standard datasets such as Iris dataset, Boston dataset. So in that we use the Boston dataset to predict the housing price. I can rename my Jupyter notebook, that is house prediction. In Python, to perform machine learning, we require a various libraries such as pandas, libraries such as NumPy, Matplotlib, Seaborn, those sklearn. Sklearn is a very powerful library. So those who know what is this library, we can go one by one library from the next video. From next video, we start with the NumPy library. So the first step in coding, we have to import the necessary library. So first library we have to import this pandas. Import pandas as PD. Hashtag is used for the comment line, comment anything in the code. So pandas is basically used to work with data frame. The next library I have to import is NumPy. NumPy is useful to work with numerical operation. Next is matplotlib.pyplot as PLT. And another is import Seaborn as SNS. The Matplotlib and Seaborn library both are useful to visualize the data. For the data visualization, we use that library. And another library is import OS. By using this library, we can change our working directory. Okay, so my working directory, my file is in pandas folder. So I can change my working directory and get my file from that folder. So therefore I have to type os.change directory. So change directory, I have typed chdir and my directory is pandas. And in Jupyter notebook, you have to simply click here to run, or by using keyboard, you press shift enter. When this asteroid is get converted into numerical value, this cell is get run properly. Yes, it shows the error, that is matplot. Okay, matplotlib. Okay, so this is a typing error. I just write the matplot. So run it again. So wait for a second, it will run. Okay, the asteroid is converted into number. So next is import file. So we name is a data frame. From data frame we take a short form. Then from importing file from this pandas, we use the command, that is pd dot read under csv boston dot csv. Okay, so my data frame, my data set is Boston CSV. Boston is the standard data set, so I can run this cell. So I can successfully import my data. So I can comment it here. So import data set, and I have to see how numerically look my data. So therefore I just write, I have to see that that first 5 to 6 rows or column how it's look. Therefore I just write df.head. Okay, so here it shows the first 5 column, 5 rows, sorry, and total I think there are 13 or 14 columns. So we don't know right now how many rows and columns. But df.head, if we use that close parenthesis, then it shows the random 5 rows. If we put it number here such as 2, then it shows the 2. Remember, in Python the numbers start with 0, so it shows the 0 and 1. So it is this is 0 and this is 1. This is my index, and that is the unwanted column that is created. So I have to remove this, and I have to say that is unnamed 0, it is my index. So I just simply have to write it here, index column is equal to 0, and I have to run. You can see that my unnamed 0 column, it get converted into index. So I just erase it and say keep it by default, and it shows the df. So my dataset look like this. So I don't know what is it: crimes, hidden, index, chaos, knock, rm, age, that it is. So I have Googled it, and then I get a very wonderful file to explain what is the Boston dataset. So I can show that. So this is the file. I can provide a link below. So the first column is crime. So it says that per capita crime rate by town. Okay. The second is ZN, proportion of residential and zone for lot over 25,000 square. So it's my request to go over this file. I can put link below in description. So move towards our code. So next is I want to check information of my data. Okay, so data having total memory usage 59.3 KB and having all values in float, that is rad and taxes is in integer, the all is non-null value. So again I have to check what is the shape of my data set. Okay, the shape says that the first number is represents row and second number is represent my column. So in that shape, the Boston dataset has 506 rows and 14 columns. Next is I want to check what is the size of my dataset. So I just enter size, then it shows the 7084. That is this is my size of my dataset. Next, I have to get more information about my dataset. So just type it df.describe. Okay, so df.describe, then your each feature is represented here with its mean value, its standard deviation is minimum value, its maximum value. Your each and every feature, the details about each and every feature described in that cell. So there are one more trick to visualize greatly, that is we have to create transpose of this. Tada! See here, you can visualize more effectively. So to perform machine learning, we have to create a variable such as x and y. So x is my feature and y is my all target variable. So you can see that in this particular dataset details, that is MEDV is nothing but median value of owner occupied home in $1,000. Okay, so this is my sales price and this is all is my feature. This is my feature and this is my MEDV is my label or my target value. So in X, I just say that df that drop so here I can extract my feature from label. So my MEDV is my label, so I can remove from that feature and say as X is my all feature, X contains my all feature. So I can see that shape of X. Sorry, typo error. So you can see that my whole data set having shape of 506 and 14 column. But here in X I can drop my one of the column, that is MEDV. So it gets successfully deleted or successfully removed instead of I say deleted. So in next step I have to mention my label here and I can check shape. Okay, so 506 rows and 1 column. So next I can visualize my data using matplotlib. So therefore I have to write plt dot scattered x h y. So I can mention my dataset looks in a green color. Then size of my dataset. So you can see this is my dataset is look like. So in linear regression, basically we can do that. We have to pass a best fit line from my dataset, and the point from that line to the nearest data point, we have to calculate mean square error, and for a greater accuracy, I have to very less mean square error. So by using Seaborn library, we have to just pass a best fit line by using this age and my MEDV two features. Age is one feature and MEDV is my label. So just created, I have that. So ns is rich plot x is equal to tf h y is equal to tf. Okay, and here you can see that the line is passing from the dataset. It is my best fit line. Okay, so after a data visualization, I have to split my data into train and test dataset. Okay, so for that I can use sklearn library from sklearn.model selection import train test split. Enter. So I have to define x test, x train, y test, Y train. But basically, the we are new to the machine learning, so I can use the standard terminology. Then I can define my variable, that is x and y. Test size equal to 0.3, random state equal to 42. So basically, why we perform train and test to divide our dataset into train and test split. Okay, the motto of this train and test is to convert my dataset. The half of my dataset is provided to train the model, and remaining test dataset used to evaluate what is the performance of my model on real world application. So here I can converted my model into train test split. I just enter shift enter. Okay, the typing error, sorry for that. Here, okay, here my data is get train and test is get separated. So next step is to I have to create my model. So first of all, I use a linear regression model. So you can just press a tab, it will get you what you have to type next. Okay, so from sklearn.linear model I have to import linear regression, and right now I'm creating my model. Okay, so from here I can create my model successfully. The next step is to I have to fit my model to training data set. For that I can use xtrain, ytrain. Yes, my data set is fitted very well. The next step is to create a y predict. Okay, so model dot predict x test. Okay, so I can create my model, I can fit it, and the next step is to check whether my model having great accuracy. So in linear regression, to verify if my model is having a greater accuracy, the first that we have checked this by using two parameters. The first is my mean square error and second is my R2 square. Okay, so first of all we have to check mean square error. So similarly, so from sklearn dot matrix we can import mean square error. We say mean square error y test and y predict. Okay, so my mean square error is 25.94. okay, so the next step is to check my R2 square. If my R2 square we have my R2 square is in between 0 to 1. So if my R2 square is nearby 1, it means my all data point is well fitted, is very near to my regression line, that is my best fit line. So I have to check whether it will best fitted or not. Learn dot matrix import R2 score print R2 score. So simply I have copy paste this term. Okay, so my R2 score is my R square. R square score is 70%. So simply I can multiply this by 100. Okay, so it will show in 70%. So 70% of my data points are in well fitted, so it will show a very good accuracy. So I can check it if it's predict same or it will show some error. So basically, if my mean square error is around $25 and my that R square score is 70%, check my prediction by using this command clf.predict, and I know this is my all feature except this MEDV, so I can simply copy paste this all and paste it and just remove that. So here is, I can run this cell. So sorry, so my model name is model. Okay, so here it is my output. So my prediction for this point, my predict value is 29.92 and my actual value is 24.0. So I think for initially for any machine learning engineer, it's an achievement to create a model and to run it successfully. So I have run it successfully. So what we see in that particular video, we just get a recap. So first of all, we import necessary libraries, then we import the data. We just we remove unwanted cell, created an index, we check the info, we check the shape, size, we describe our data set, then we collect all my feature into X, my label into Y, I plotted my data set, then I see that is my best fit line, then convert into trend test split, create linear regression model, that is my machine learning model. I fit data, trend data, test data, and check mean square error. My data is predicted from the data point. How my model is predicted from that data point, it will show here. This is for today's video. Hope you will like this video. You can share with your friend.